There is a gap in the world map that defies logic. If you look at the globe, Africa and Asia seem to touch, separated only by a thin sliver of blue water. For thousands of years, trade, armies, and pilgrims have been forced to stop at this water's edge, relying on slow ferries or taking a massive 1,000-mile detour around the perimeter. This is the Strait of Tiran. It is only 8 miles wide. In the world of modern engineering, 8 miles is nothing. We have built bridges 3 times that length and tunnels that dive far deeper. So why does this gap still exist? Why, in the 21st century, can you not drive from the Sinai Peninsula to the Arabian coast? The answer isn't a lack of money, and it certainly isn't a lack of ambition. The reason this bridge hasn't been built is that the Red Sea is not just a body of water. It is a tectonic scar. To cross it, engineers must battle an active earthquake zone, waters that drop into an abyssal canyon, the height of a skyscraper, and an ecosystem so fragile that a single mistake could wipe out one of the planet's last great natural treasures. This is the story of the proposed King Salman Causeway, a $4 billion gamble to physically suture 2 continents together. It promises to revolutionize the global economy, but the engineering required to build it pushes the very limits of what human beings can construct. To understand why this project is such a nightmare, we have to look beneath the waves. The Red Sea isn't a normal sea, it is a rift valley. It is the place where the African tectonic plate and the Arabian plate are actively tearing away from each other. The proposed site connects Ras Al Sheikh Hamid in Saudi Arabia to the resort city of Sharm el Sheikh in Egypt, using Tiran Island as a stepping stone in the middle. On the surface, it looks perfect. But underwater, the terrain is hostile. While the coastal shelves are deceptively shallow, the seafloor suddenly collapses. In the deeper sections of the strait, the bottom plunges to nearly 900 feet, roughly 270 meters. To put that in perspective, if you place the Statue of Liberty on the seafloor, the water would still be 600 feet above her torch. Standard bridge foundations cannot simply be dropped into an abyss of that magnitude. The pressure at that depth crushes standard equipment, and the sheer height of the support pillars required would make them some of the tallest structures on Earth before they even break the surface of the water. And remember, these pillars wouldn't be sitting on stable bedrock. They would be standing on a fault line that is slowly ripping itself apart. So how do you cross a tectonic rift valley? Engineers have spent years paralyzed by a choice between 3 options, each with a fatal flaw. Option 1 is a suspension bridge. This offers the most iconic visual, a soaring structure linking 2 worlds. But suspension bridges are vulnerable to high winds, and the Red Sea is a wind tunnel. The region is plagued by intense heat and sudden, violent gusts. Furthermore, a suspension bridge requires massive anchorage points on either side. In a seismic zone, the tension cables holding millions of tons of steel and concrete must be able to withstand the ground literally moving beneath them. If the earth shifts, the bridge has to dance with it, or it snaps. Option 2 is a tunnel. Tunnels, like the Channel Tunnel between Britain and France, are immune to wind and weather. But a tunnel here faces the pressure problem. At 900 feet deep, the water pressure is immense. And unlike the English Channel, which has a relatively consistent chalk seabed to bore through, the Red Sea geology is fractured and complex. You aren't just digging through rock, you are digging through a crime scene of geological violence. Ventilation becomes another hurdle. Moving cars through a 20-mile tube requires massive air exchange systems to prevent carbon monoxide poisoning, which adds billions to the cost and years to the construction time. This leads to the third, and most likely, option, the hybrid. This design mimics the Øresund Bridge between Denmark and Sweden. It would likely use a causeway and bridge system for the shallow waters near the Saudi and Egyptian coasts, transitioning into a tunnel or a high-span suspension bridge for the deep water navigation channels where massive oil tankers and container ships pass. By using Tiran Island in the middle as a natural anchor, the project can be split into 2 manageable halves rather than one giant, impossible leap. However, even if the structural engineering is solved, the environment declares war on the materials themselves. The Red Sea coast is one of the most corrosive environments on the planet. The combination of extreme salinity in the water, high humidity, and scorching desert temperatures creates a chemical cocktail that eats steel for breakfast. Concrete in this region suffers from something something called chloride attack, where salt penetrates the porous stone and rusts the reinforcing steel bars from the inside out. When steel rusts, it expands, cracking the concrete and causing the structure to crumble. To build a bridge here that lasts for 100 years, engineers cannot use standard materials. They would need to use high-performance concrete mixtures cooled with ice during the pouring process to prevent heat cracking. The steel would require advanced epoxy coatings or cathodic protection systems that run an electrical current through the metal to fight off corrosion. Every single bolt, beam, and cable would need to be armor-plated against the air itself. And then there is the heat. Construction crews would be working in temperatures that regularly exceed 45 degrees Celsius, 113 degrees Fahrenheit. This isn't just uncomfortable. It changes the physics of construction. Metal expands in the heat. A bridge of this length could expand and contract by several meters between day and night. Expansion joints, the metal teeth you see on highway bridges, would need to be engineered to handle massive thermal shifts without buckling the road surface. There is a cost to this project that cannot be measured in concrete or dollars. It is measured in life. The Strait of Tiran is the lungs of the Red Sea. It is home to some of the most spectacular and resilient coral reefs on Earth. These aren't just pretty rocks. They are a biological anomaly. Scientists have discovered that the corals in the northern Red Sea have a unique genetic tolerance to heat. While reefs in Australia and the Caribbean are bleaching and dying due to global warming, the Red Sea reefs are thriving. They may be the seed bank that saves the world's oceans in the future. Building a mega project here puts a loaded gun to the head of this ecosystem. The construction process involves dredging, digging up the seabed to place foundations. This creates massive plumes of sediment, thick clouds of underwater dust. When this sediment settles, it blankets the coral, blocking the sunlight they need to survive and choking the polyps. It is the equivalent of burying a forest in volcanic ash. Furthermore, the noise of pile driving, huge hammers pounding steel into the crust, travels 5 times faster in water than in air. This acoustic trauma can kill fish larvae, shatter the hearing of dolphins, and drive marine life away from their breeding grounds forever. If the bridge is built without absolute precision, we might gain a road to Asia, but lose the most climate-resilient ecosystem on the planet. Despite the risks, the earthquakes, and the engineering nightmares, the political will to build this connection is stronger than ever. Why? Because the economic reward is staggering. Currently, trade between these two massive markets is inefficient. A direct road link would transform the region. It would allow goods from the factories of Europe and North Africa to reach the markets of the Gulf in days, not weeks. It would facilitate the movement of millions of pilgrims traveling to Mecca and Medina, replacing dangerous and crowded ferry journeys with a smooth drive. But more than that, this bridge is the linchpin of a new future for Saudi Arabia. Just north of this proposed crossing lies Neom, the kingdom's $500 billion futuristic megacity. Neom is being built to rely on connectivity. This bridge is not just a road, it is the physical umbilical cord that connects this new futuristic hub to the African continent. It is estimated that the travel time between the continents would drop to 20 minutes. Imagine that. You could have breakfast in Egypt and lunch in Saudi Arabia. The psychological barrier between Africa and Asia would simply vanish. The project to bridge the Red Sea is a test of human arrogance against the forces of nature. It is a battle against depth, heat, salt, and seismic activity. It requires us to pour concrete into a fault line and drive piles into a coral garden. From an engineering standpoint, it is possible. We have the technology to conquer the abyss, but the question remains, can we do it without destroying the very beauty that makes the Red Sea unique? As plans move forward and billions of dollars are allocated, the world watches and waits to see if we can truly stitch the continents together. The distance is only 8 miles, but it is the longest 8 miles in history. If you want to see more breakdowns of the world's most impossible engineering challenges, make sure you are subscribed. We are tracking the biggest mega projects on Earth, and you won't want to miss what's coming next. Thanks for watching.